for many people is not known when the wind energy become an alternative energy source. The roots are in the 1973 oil crisis, which triggered a high interest in wind turbines. Today, the wind energy sector is called to be one of the main pillars of the energy transition. The growth has been awesome. By the end of year 2000, 16 gigawatts were producing electricity. Another 700 gigawatts have been added in the following 20 years. Let's see which are the projections for the next 30 years. Being impressive what has been achieved. This is just the start of an explosive growth. To achieve the goal of net zero emissions by 2050, the way we consume energy is to be modified. Many sectors will require an effort to achieve a real decarbonization. For that purpose, measures considering energy efficiency as well as free CO2 energy sources need to be implemented. Electrification of the economy will be key, and the increase of renewable energy sources critical. International Energy Agency is forecasting that more than 8 terawatts of wind energy capacity will be required. The projections are very promising. Is the wind energy sector prepared for it? There are several questions to properly answer to this point. In this video we are gonna focus in the wind turbine industry and we will leave for later discussions other components of the value chain. Provided there is an energy market demanding for wind energy, there are two fundamental questions. The first one is related to the industrial capacity of delivering an average more than 250 gigawatts per year. This is quite a large figure if we compare it to the 70 gigawatts being delivered last year. The second one is related to the technological development that will be needed to satisfy that demand. Beyond the capacity demanded, there is also a need for costs and performance. Hopefully we will be able to provide some insights and food for thoughts. Let's first take a look into the OEMs. The chart is providing as a color map of the rankings. Red is for out of the top 10, yellow for the top 10 and green for the top 5. As we may expect, some companies appear and disappear from the main rankings. There are some of them that consistently appear in the top positions. This is very relevant because it shows which of them have been able to grow with the market and so will be of interest to study them. Only 4 companies have remained in the top 5 for the last 7 years. It is also remarkable that these 4 companies account for more than 50% of the market. Let's get some information for some of the top performers. Best way is to access that info that is publicly provided by them. Being listed companies, and devoted to the wind energy sector, we will fix our attention in Siemens Gamesa Renewable Energies and VESTAS. First item we will pay attention to is the ASP or average sales price. For both companies, the evolution is very similar. Since 2006 the price per megawatt has decreased from 1 million euros down to 0.7 million euros in average. This is reflecting a high pressure and demand from their customers. LCOE, as we have explained before, is critical in the energy sector, and capex is the item that is receiving an extraordinary attention. How this pressure in prices is affecting them. Now, let's fix our attention in the EBIT over revenues. For both companies the EBIT is decreasing as the ASP. We can imagine that will have a knock-on effect on the supply chain as well. But how bad is this EBIT reduction? Clearly the picture is not looking good. And if this is the case for the top performers, we can deduct how bad can be the situation for other OEMs. In addition to selling wind turbines, both companies are expanding their offer to the market. Services has become an attractive activity for them. Even though revenues are not as high as selling wind turbines, margins are way better, so as helping them to ride the situation. Let's try to dig on the causes for this EBIT performance. In terms of wind turbine power per unit, there is a clear trend last 10 years. The nameplate of an individual wind turbine has almost doubled. However, the number of wind turbines per year, disregard nameplate or global capacity installed, is relatively stable. If the number of wind turbines per year are pretty stable and the top performers are able to grow with the markets, this is a clear indication that the small ones are disappearing or acquired. Now, we have the basic information to answer the first question. There are evidences that bringing into play new technologies is one of the bigger strengths of OEMs. They have been able to reduce cost, increase size and improve efficiencies. However, they are struggling with the financials. EBIT have suffered up to a critical level, with such intensity that the weaker ones have disappeared. Obviously, the upstream supply chain is suffering the consequences. Not just because the continuous search for cost reduction, but also because the number of clients have been reduced. Additionally, the never-ending increase in size is ejecting some of them out of the business. Let's focus on the financial situation. A traditional approach, already being implemented, is to increase the size of the companies to gain financial muscle. The two mechanisms are merger or acquisitions. As examples we can bring in, we have the merger of Siemens and Gamesa, the acquisition of Acciona Windpower by Nordex, the buyback of MHI VESTAS by Vestas, the acquisition of Ecotechnia by Alstom and subsequent acquisition by GE Wind Energy, and many others. Others couldn't survive, as the most recent example of Senvion. Another way of dealing with the financial weakness is company efficiency. Most of the companies have implemented measures to cut down costs, reducing personal or working capital. And finally, they are trying to optimize the supply chain. Sometimes through a vertical integration, and using external suppliers to level the production peaks. Also transferring to them guarantees, imposing just-in-time delivery conditions, or adjusting the payment conditions. This is solving the short-term problem on the financial side, but at the same time, this is creating a potential bigger problem in the long run. The supply chain is becoming weaker and weaker. Now we can try to answer the second question. Are there new technologies, or business redesigns, that may help in strengthening both the financial muscle and the supply chain health? Manufacturing technologies should be a priority. As machines are becoming bigger but quantities are not increasing, no proper volume effect is helping to absorb development costs. Just-in-time techniques, trying to reduce working capital, are not helping as well. For that reason, additive manufacturing, or similar technologies, could be a solution. The continuous push for bigger nameplates is not healthy. GE made public the amount of money needed to bring to the market the new Haliade X with a 12 megawatts tag. The declared investment was over $400 million. If volumes are not big enough, the capacity for absorbing such an investment is limited. OEMs and their clients should find a reasonable agreement. The core competitive advantage of an OEM is located in the rotor design and the control. Should all OEMs be able to reach an agreement for common components not involving their core competences, may have huge advantages. If nameplate increase rates can be slowed down and they can focus in the core components, the effort should be concentrated in the efficiency of the manufacturing processes and the rotor performance. Cost of raw material can be softened if proper use of recycled materials is implemented. Is not only about recycling a wind turbine once its life is over, but using those recycled materials, and others coming from different sectors, in the manufacturing of new wind turbines. Just as an idea, the incorporation of recycled carbon fibers may be done at a very competitive cost. And finally, maybe it's time to look for very radical solutions. Many startups are trying to bring wind kite solutions into the market. The main advantages are that at higher altitude you can find better wind resource and weight per megawatt is much lower than in a traditional wind turbine. Is it the right time to abandon the traditional wind turbine concept? There are alternatives enough to ensure that the future of wind energy can be as fruitful as has been its past. Thanks for watching.